So we are going to do a utility portfolio choice. No question. You can send me a private message if you ask it to ask. But anyway, there's no one who came with any questions. So it means that I'm going to start on portfolio choices. So on portfolio choice, we are trying to maximize, we are trying to construct a portfolio using a person's utility, right? So under mean variance portfolio, we saw that you can construct a portfolio trying to minimize variance. Or when you use Markowitz model, you could specify the returns of a portfolio you want to make, and then you try to minimize the variance. So at the end of the day, variance had to be minimized. So now we want to maximize our utility. We want to maximize our utility. Okay, you can see that the color is no longer good. We're trying to maximize our utility right now. So so we're trying to make a portfolio through maximizing our utility. So we are maximizing our utility function of X, right? So remember that there's a expected utility theorem, which tells us that you can actually find a percent utility of wealth for a future date. And you can make the decision in such a way that you are maximizing the utility based on the expected payback in the future, right? So before I talk about this, we have to, okay, I just have to add something here. Our constraint is going to be our wealth, right? Our constraint is going to be the number of shares we buy should always be less than our wealth, less than or equals to the wealth we have, right? So before we start here, we have to define our variables, right? So to define this thing, I will do P is the price, right? So price of security. So P is the price of security. D is going to be the payoff of the security, right? W, we all know is going to be the wealth of so it's going to be the wealth. What else has to be known? X, which is mostly important, right? X is going to be our payoff, right? It's going to be our, I will define it as the state payoff, right? So in order to understand this, let's say maybe we have two securities. We have security one, and security one has price one and has two payoff. I will say payoff gonna be A and B, right? Under the state. So you have two states. Actually, I think I just say capital. So I will say A and B. So we have two states. We have state one and state two, right? And then we have security two, again has price two. I mean, like, yeah, and they pay out, and they pay off after a period. It's gonna be let's say C and D, right? So only one state will happen, right? Only one state will occur. So to calculate your payoff, to calculate the payoff, the payoff, to calculate the payoff, you will have to calculate payoff per state. So under state one, if state one happen, it simply means that depending on the amount of shares you bought. So if you bought sigma, again, what's this sign again? If you bought this amount, so this is, yeah, theta. So if you bought a theta amount of portfolio one, the payoff is going to be that amount theta A, I mean like theta of portfolio one times the payoff, right? Plus theta two times the payoff of C. Again, the payoff C, right? So the payoff will depend on the state. Only one state will happen. And this is the state which will happen. Either state one will happen or stage two will happen, right? This is for state one. So if stage two happen, the payoff will be the number of shares you have bought times the payoff, again, times the number of shares you bought times the payoff is going to be D. So this is how you find your answer. So this is for stage two, right? So you cannot have amount in that interchange. So you can't say that, okay, after 1 year, we expect asset one to be under a different state than asset two. Only one state will happen. And whatever state happen, that is how much you are going to have actually in your shares. So if you bought, again, let's say maybe you have 10 rand. Let's say you have 10 rand, right? And asset one cost 5, and even asset two cost 5 rand, right? So let's just say maybe for simplicity, again, I'm like for simplicity's sake, you have bought one share for asset one, and you also bought one share for asset two, right? So this is supposed to be 2. So you have bought one. You can see that this amount is actually going to amount to 1, right? So it simply means that the payoff is going to be again under state one. The payoff for state one is going to be equals to A plus C. And then let's say maybe you have bought again, let's just say maybe the prices now for asset one is going to be 250, and then for asset two is going to be 250, and then you bought one share for asset one, and then for asset two you bought 3 because you can afford 3. It seems simply mean that under state one, the amount of shares, again, your payoff is going to be 1 times A. It's going to be 1 times A plus 3 C. So I guess this makes sense already before we can start working on the question. Because anyway, so now we are not going to just cram that you're gonna buy 1 or 3 or 2 and 1 or 1. Now we have to find these things scientifically. We have to find our portfolio, again, the amount of shares we should buy for each security individually, and we have to find it scientifically. To find that answer, we then have to go back to this question. So how do you find that value? So I assume that most of you can now find the answer for this, but then when you write this answer in the Lagrangian, by the way, you are trying to maximize your expected utility. So your answer is going to be the utility, the expectation of the utility, U of X star. minus lambda, the sum of this minus 12. So this is going to be Lagrangian, and then you're going to solve for this. You're going to find the first derivative in terms of lambdas for your Lagrange equation, and then the answer is going to be equals to this. It's going to be this, and then chain rule, the first derivative of this, and then you're going to differentiate what is inside. And I already have explained that your x, okay, by the way, your x star is going to be equals to the sum of the amount of shares you bought times the payoffs, right? So when you differentiate this in terms of theta, your answer is going to be minus lambda pi equals to 0. In other words, you can just say this thing equals to that. So this is where that equation comes from. And then you're gonna do the same thing, but then this time in terms of lambda, the partial derivative of the Lagrange in terms of lambda again equated to 0, and then your answer is going to be the sum of all the p minus w equals to 0. So instead you can just remove the 0 and put the equal sign over here. So you will have to solve these two equations to find your answer. I hope that makes sense. So we are going to attempt a few questions. Again, does this proof make sense? It can come in the test actually. So I will give you a head start to read this question for 30 seconds, and then we can attempt it together. So please write it down as well, so that when I start, you already know what we are doing. Okay, I hope we all read the question and wrote some things down. So suppose that the market has two states, W1 and the W2. One risky asset, S, and risk-free asset with expected return of RF 10%. So the initial price of S for 100 Rand, and the payoff at the end of the period is going to be 200 Rand or 0. So assume that the probability of state one is going to be half. So solve the log normal, the log optimal portfolio. Okay. Okay, and again, so we didn't do this one. So I am going to cancel this thing of log optimal here. And then I will say that suppose that your utility function of Wolf is going to be equals to ln of x, right? So again, and sorry for that actually. So anyway, if this is the case, how? Okay, so you may assume that the initial Wolf is W, right? So this is gonna be your utility function. So you have two equations. So you have one risky assets asset S. So risky asset S has the price of how much? Has a price of 100. and the payoff will depend on the state. It's going to be 200 or 0. And then you have a risk, again, you have a risk less asset. Riskless, didn't see how much their price is. Did they say their price for asset? They didn't say how much their price is, right? So, but then we know that the payoff is going to be, again, let's just say it has 1, price of 1. And then the payoff is going to be 1,1 and 1,1. Because it pays 10% interest rate. Are we still together? There is no question over here. So I am going to put down the variables together. So I can see on my computer that we are running out of time. We actually have less than a minute. So when the computer switch off, please log in again, and then so that we can start again. But then I am going to stop here so that we can re-log in again.